Hey everyone, welcome back. This is a quick review of our conic sections, and we're getting ready to start studying the ellipse today in chapter 10.3. But I wanted to review conic sections first. So let's just talk about a conic section. A conic section is a section or a slice through a cone. All right, so if we take different slices through a cone, you can create the circle, the ellipse, the parabola, and the hyperbola, depending on where your section is or your plane that you cut out. If it's straight through parallel to the base of your cone, you make a circle. If it's at a slight angle, you'll have an ellipse. You'll have a parabola if it's parallel to the cone, and a hyperbola if you have a steep angle. So I want you to be able to see, so all the curves are related. All right, so let's first of all talk about a circle, and then we're going to move on and talk about the ellipse. So the circle. All right, when we look at the circle, it's the set of all points that are on a plane that are a fixed distance from a central point. All right, so just a few points starts to look like a circle, but then when we collect all the points, we actually have a circle. So that's where we get our definition, the set of all points on a plane that are a fixed distance from a central point. And I love this little tool here. You can just kind of draw around and see that it is the set of all points on a plane that are a fixed distance from a central point. That actually has a name. The idea of the set of all points is used so much that it even has a name called the locus. So a locus is a set of points that share a property. All right. A circle is a locus of points on a plane that are a fixed distance from the center. We talked about the circle already, so now we're going to move on to the ellipse. All right, so an example is an ellipse is the locus, or the set of all points, whose distance from two fixed points, F and G, add up to a constant. All right, so let's take a look at what we know about an ellipse. Let's come back over here to the ellipse. And see here. Go. So an ellipse usually looks like a squash circle. All right. An ellipse, we're more concerned not so much about the center, but we're concerned about these 2 points, F and G, and they are each called, F is a focus and G is a focus, and together they are called foci. That's the plural, foci. So F and G are the foci. And what's interesting about these 2 points is the distance from F to P, and is always the same value. So F to P and P to G. When we add those 2 lines up, we're going to get the same distance every single time. So as you can see, G and F are in the same spot, but they're just different numbers, but they add up to the same constant every time. All right, so just as a quick example, let's say this distance, the full distance from F to G is 10. All right, so we might see F to P might be 7, so P to G would be 3, because that would add up to be 10. All right, and another example, F to P might be 5, and then P to G would have to be 5 also, so they would add up to 10. It's always going to be a constant, the same. Here, F to P might be 4, P to G might be 6. Here, F to P might be 1, so P to G would be 9. So the main thing to know is when we go from point F to any point on the ellipse and then go to point G, we always travel the same distance. All right, so it's always the same distance, and that makes the definition of an ellipse. A few other things about an ellipse. A circle is actually an ellipse where both the foci are at the same point, which is the center. In other words, a circle is a special case of an ellipse. All right, so the definition again of an ellipse is the set of all points on a plane whose distance from 2 fixed points, F and G, add up to a constant. So that actually is the definition of an ellipse. All right, a couple more things for you to know. An ellipse has a major axis and a minor axis. The major axis is the longest diameter. Remember, the diameter goes through the center, and the minor axis is going to be the shortest diameter at the narrowest part of the ellipse. And it changes, it can change. So did you see now as I stretched it, my major axis changed because C to D is now longer than AB. So I go a different direction. Now C to D is shorter and A to B is back longer. So now it's the major axis. Another thing to know is we have a semi-major and a semi-minor axis. These are just half of the major and half of the minor. And that again changes as the size of your ellipse changes. The other thing that I want you to know is about a tangent. This is interesting about the tangent. The tangent is the line that touches at the curve just at one point without cutting across it. So here's a tangent to an ellipse, and notice that the tangent is the line has equal angles with the two lines going to each focus. So as I move my tangent or my point P around, notice that my angles stay the exact same. All right. Again, they stay the exact same. No matter where I move my P, those two angles stay the exact same. I get right straight in line, I get a 90-degree angle. And notice if I put my two foci on top of each other, I end up with a circle. All right. And now anywhere I move my P, I keep a 90-degree angle. The radius stays at a 90-degree angle to my tangent. All right, and one last thing is the equation of an ellipse. All right, by placing an ellipse on an XY graph with its major axis on the X axis and minor on the Y, the equation of the curve is going to be x squared over a squared plus y squared over b squared equals 1. All right, now there's a different equation, it's a little bit different, and we'll talk about it in our next video, for if the major axis is on the Y and the minor is on the X. So I'm not going to get into that quite yet. And we can talk about the equation of the hyperbola real quick. It's going to be the exact same thing, except instead of plus, it's going to be minus. So here's your equation of an ellipse with the major axis on the X and the minor axis on the Y, x squared over a squared plus y squared over b squared equals 1. So that's a general information about cones and ellipses, the conic sections, specifically ellipses. If you would like to work with this calculation tool a little bit more, move the ellipses around, I really highly recommend this mathisfun.com, and you can see for yourself a little bit more about how this F and G specifically add up to the same constant every time. I think this is the best illustration that you can see. Okay, so turn this video off and now go to lesson 10.3, and I'm going to work on using the equations and actually doing some math problems with it. So I'll see you back in a minute on lesson 10.3.